Hey, Algebra 2. We're starting chapter 10 today. It's a tough one, okay? So, lesson 10.1 is called graph, sine, cosine, and tangent functions. Now we're talking about actual graphs of things. So let's dive in. Please take your time and take notes and highlight the book that I copied for you, etc. Okay? First of all, let's find the sine, cosine, and tangent of pi over 2. If we remember, pi over 2 is 90 degrees. Sine is my y value, cosine is my x value, and tangent is y over x. So at 90 degrees, sine equals 1, cosine equals 0, and tangent is undefined, because I can't divide by 0. Okay, 2 pi is 360 degrees. Sine is 0. Cosine is 1. And tangent is 0 divided by 1, or 0. The diameter of a wheel is 27 inches. Through how many radians does a point on the wheel move when the wheel moves 15 feet? So I have a diameter is 27 inches. Through how many radians does a point on the wheel move when the wheel moves 15 feet? So we're here, and the wheel rotates. Okay, how many times does the wheel rotate over 15 feet? So I went offline to do some of the work here. So I know that 27 inches is equal to 2.25 feet. I just did 27 divided by 12. You're welcome to work along, grab your calculator and do some calculations. I then used that 2.25 feet and found the circumference of that wheel. So 2.25 times pi gives me 7.07 feet. How many times does 7.07 go into 15? Did some division here and got 2.12 rotations. So 15 feet, if I rotate my wheel for 15 feet, I actually rotate my wheel 2.12 times. It goes around 2 and then 0.12 times. Well, I know that one full rotation is 2 pi, which is 360 degrees. So if one rotation is 2 pi, how many rotations is 2.12? So I did 2.12 times 2 pi and got 13.3 radians. Cool. All right, let's learn. In this lesson, you'll learn to graph functions in the form y equals a sine bx and y equals a cosine bx, where a and b are positive constants and x is in radian measure. The graphs of all sine and cosine functions are related to the graphs of the parent function y equals sine x and y equals cosine x. That's always where we're going to start. Okay, we're going to start there and shift and stretch and move, etc. Okay, so these are our parent functions below. Y equals sine x always starts through the origin, has an amplitude of 1. That means I go up a measurement of 1 and down a measurement of 1. Has a period of 2 pi. That means it repeats every 2 pi. You're welcome to highlight and keep it there. But I start at the origin, I go up, down, I go back to the x-axis. That is my period of 2 pi. That is how I repeat. The range is the y value, which will be the top maximum of 1, minimum of 1. That's the range. A sine function bounces back between 1 and -1 and repeats. What else can I tell you? Can't think of anything. All right. Cosine function always starts at y equals 1. Its amplitude is also 1. Its range goes from -1 to 1. Period is 2 pi. So that's where it repeats between x equals 0 and x equals 2 pi. If you look, everything else is the same. Okay, we'll get into what these values are in a second. These are all the same. The only difference is the cosine value starts at y equals 1 and the sine starts at y equals 0. Cool? Alright, let's get rid of this. Awesome. Alright, to summarize, the domain of each function is all real numbers. If you remember, domain is the input, or the x values. The range of each function is -1 to 1. The minimum value at each function is little m equals -1. The maximum is big M equals 1. The amplitude of each function graph is half the difference from the maximum and the minimum. Okay, 1/2 big M minus little m. That is my amplitude. So here I have 1/2 1 minus -1, which is 2. 1/2 of 2 is 1, so our amplitude is 1. Each function is periodic, which means that its graph has a repeating pattern. The shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is called the period. Each graph shown above has a period of 2 pi. That's when it repeats, is 2 pi. The x-intercepts for y equals sine x occur at 0, pi, 2 pi, 3 pi, etc. Okay, that's where it repeats. So it crosses the x-axis at pi, and then again at 2 pi, which is the full period here. Then it crosses at 3 pi, and then 4 pi would be the next period. The x-intercepts for y equals cosine x occur at the 90 degrees. Okay. So if you think about the unit circle, if I talk about sine for a second, sine is my y values on the unit circle, right? Where is y 0? Well, y is 0 here and there. So if I have my unit circle, I know where sine is 0. If I take that information, and I graph the function, I know at x equals 1, y equals 0, I'm right here. And then I hit y equals 0 again at 180 degrees, or pi. So there's pi. And then I hit it again at 360 degrees, or 2 pi. So that right there is one turn, if I do this, one turn around the unit circle. So I hit 0, y equals 0, at pi, or 180 degrees, and then again at 2 pi, or 360 degrees. So my unit circle going, just keep on cycling, translates into a graph like this. We can do the same thing for cosine, where we're zeros at, let's do this actually. sorry, you hear my dog. X equals 0 right there. So if we took that from the unit circle and graphed it, okay, cosine is my x value, so I know I'm going to be 0 here. I'm going to cycle around. Sorry, let me redo that. I want to know where I'm hitting my x-axis, right? So I hit it at 90 degrees. Sorry. And then again at 270 degrees. And back up and complete the cycle. So my cosine value is x. So over here, x is 1, x is 0, x is -1, x is 0, x is 1. So that's how we go x is 1, 0, -1, 0, 1 as we go around the unit circle. Phew. All right, we're still learning, I know. Be patient, it's a tough one. So the amplitude and period of the graphs y equal a sine bx and y equals a cosine bx. This is what we need to remember. Okay, we talked about the parent functions are y equals sine x and y equals cosine x. Now we're going to mess with it a little bit. Okay. The amplitude and period of the graphs y equals a sine bx and y equals a cosine bx, where a and b are non-zero real numbers, are as follows. Amplitude is always the absolute value, and the period is 2 pi over absolute value of b. Okay? So when we graph our functions, we really graph key points and then draw a curve through it. So each graph below shows 5 key x values on the interval between 0 and 2 pi over b. That would be one period that you can use to sketch the graphs y equal a sine bx and y equal a cosine bx for a is greater than 0 and b is greater than 0. These are the x values where the maximum and minimum values occur and the x-intercepts. So this is what we're graphing, right? If we look through the first example, starting at 0, 0, I've got a maximum, a minimum, sorry about that, maximum and a minimum, and I complete one full period. We know the maximum is 1/4 times 2 pi b, comma a. Okay, the minimum is 3/4 times 2 pi b, comma -a, right? We go through the x-intercept. We go through the x-axis. Start at 0, 0. We're halfway there. So start at 0, 0. I'm a quarter of the way there, halfway there, 3/4, and one full rotation. We start up here, quarter of the way, halfway, 3/4, and a full rotation. Okay, 5 key points: beginning, end, middle, and quarter, quarter. Okay, 1, 2, 3, 4, 5. Beginning, end, middle, and a quarter of the way, and 3/4 of the way. Okay, I kept the graph that the book threw in here, but we need to work through all the points. All right? So we're going to do A. I know that here my amplitude, A equals 4, and my period is 2 pi over b. Sorry, I've got A equals 4, B equals 1. So 2 pi over B is 2 pi over 1 or just plain old 2 pi. So now my amplitude is 4 and my period is 2 pi. Cool. Okay, let's go through the intercepts. My first one is going to be 0, 0, because it's where I'm starting. Then I'm going to have 1/2 times 2 pi. And then I'm going to have the end. That middle one works out to just pi. Oops. So I have my beginning, my middle, and my end. Now we need the maximum. It's going to be 1/4 times 2 pi. A. And my minimum is going to be 3/4 times 2 pi negative A. So this gives me pi over 2, comma 4, and 3 pi over 2, comma negative 4. So I have beginning, middle, end, and 1/4 of the way through and 3/4 of the way through. Okay, these all translate up here to beginning, middle, end, 1/4 of the way through, and 3/4 of the way through. And we have enough points to graph it. Okay, let's try B. Okay, cosine. Remember, cosine doesn't start at the origin, but we still go through the same steps. I've got that page in front of me where we talked about the bits and pieces of cosine 4x. Here I know A is 1 and B is 4, so I can figure things out. My amplitude, A is equal to 1. The period is 2 pi over B, where B is 4. So 2 pi over 4, which reduces to pi over 2. And now I need my intercepts. Here I have 2 intercepts where it crosses the x-axis. For cosine, it's 1/4 of the way through. So 1/4 of the way times my period, comma 0, which is pi over 8, comma 0. That's one of them. The other one's going to be 3/4 of the way, comma 0, which equals 3 pi over 8, comma 0. I have a maximum 0, comma 1, and pi over 2, comma 1. And then I have one minimum, and that's going to be halfway distance. Which equals pi over 4, comma negative 1. Gather all my data. I have a minimum, a maximum, intercepts. So 1, 2, 3, 4. What am I missing? 2 intercepts, a maximum and a minimum. 2 intercepts. Sorry, 2 maximums. Silly me. So if we take these and graph them, my first intercept is pi over 8, 0. My second intercept is 3 pi over 8. Then I've got a minimum and 2 maximums. I hope the fractions don't confuse you too much. We're just taking pieces of a circle. So it's always just a circle. Actually, no, I'm sorry. We're just taking pieces of a whole. If we take that period of pi over 2, which is 90 degrees, we're breaking that into equal pieces. So here we know our period was pi over 2. So that right there is one period. I need to break that into equal pieces. So pi over 2, we can do half of that, which is half of a half is a quarter. Okay, I think the fractions may be difficult, but we're just breaking the period into equal pieces. 4 equal pieces, so divide everything by 4. Alright, we'll practice a few more. Okay, we're going to take our time on this, right? So, cosine function, I know I need my amplitude is 1. Sorry, here we have A equals 2, B equals 1. So my amplitude is not equal to 1. My amplitude is equal to 2. My period is 2 pi over B, where B is 1. So 2 pi. We need our intercepts. And for cosine, there are 2 intercepts. I do 1/4 times my period, comma, 0, equals pi over 2, comma, 0, and 3/4 times my period equals, let's see, 6 pi over 4, which is 3 pi over 2. So those are my 2 intercepts. My maximum is going to be always at 0 amplitude, and the full period amplitude, right? So that gave me a maximum and a maximum. The minimum is going to be halfway distance. Halfway is the period, and negative A, which is right there. I should finish my math. Half of 2 pi is pi, negative 2. So we have the maximum, the minimum, the intercepts, and we can graph all those pieces and parts. So pi over 2, 3 pi over 2, maximum, minimum, maximum, and then draw a nice curve through it. Okay. Oops. The amplitude is 5, B is 1. Sorry, I'm getting my cheat sheet out. There we go. So I have amplitude and period, B, so let's find the period. 2 pi over B, B is 1, so my period is 2 pi. Here we have 3 intercepts. we start at the origin, and then we go halfway distance. And then we go to the end. So my intercepts, I have the beginning, the middle, and the end, which I can graph the beginning, the middle, and the end. Hit our maximum is going to be 1/4 of the way times our amplitude, which is pi/2, 5, and then our minimum. It's going to be 3/4 of the way in a negative amplitude. So that is 3π/2, -5. So we have our max and our min, and if we plot them, we've got π/2, 5, and 3π/2, -5. Here we have, I know I have a pi there, but let's just treat it the same. And amplitude is 1, b is pi. So the period is 2π/b, 2π/pi, or just plain old 2. Okay, so this actually gets just a tad bit easier. If we do our intercepts, we're always going to start at 0, 0 and end at 2, 0. That middle one is going to be halfway. So 1/2 times 2, 0, which equals 1, 0. So I have 3 intercepts, which I can graph 1, 2, 3. And then a max, which is halfway. Sorry, 1/4. 1/4 times the period with the amplitude. A 1/4 of 2 is half. And then the minimum is 3/4 of the period, negative amplitude. So I have 3/2, there's no pi, -1. And then we go ahead and plot those, maximum and minimum. Okay, last one. So here my amplitude is, gosh darn it, my amplitude is 1 and my b is 4π. So the period is 2π/b, which equals 1/2. That's tiny, right? So let's break that up. I have 2 intercepts with cosine. The first one is 1/4 of the way. That gives me 1/8, 0. And the other one is 3/4 of the way. And that's going to give me 3/8. So intercept, intercept. If I plot those, I'm at 1/8 and 3/8. And then the maximum is going to be at the beginning, 0, amplitude. And then again at the end, which is the full period, comma, amplitude, and then the min is halfway. So halfway, the half distance of the period, comma, negative amplitude. So that's going to be 1/4, -1. So maximums, minimums, go ahead and plot them. Maximum, minimum, maximum, and you've got your graph. It gets easier as you go, huh? Okay, we're actually going to stop there, and I'm going to let you practice those before we move on. Okay?